Hello, this is Paul Nyujukian, one of the authors of this conference paper and the director of the Brain Interfacing Laboratory at Stanford. I'm going to briefly introduce our new computational platform called LiCoRICE. LiCoRICE is an open-source platform for executing high-level numerical operations in real time. The primary motivation behind it is to run Python NumPy-based operations on data streaming into a computer, and then transmit the results of these operations out of the computer, with the option of saving that data down to disk as well. The specific application that LiCoRICE was crafted for is experimental systems neuroscience research, but the platform is generic and has relevance to many other fields as well. Inputs to the system can be peripherals such as Ethernet, analog or digital I/O, or serial and parallel ports. These, of course, can also be outputs, in addition to output-only peripherals like displays and speakers. USB input or output devices are also supported, but need to be used with caution, as USB can cause timing issues for real-time applications. LiCoRICE itself is just a user space application layer, which runs as root on top of Linux that's been patched with preempt-RT to facilitate soft real-time guarantees. The platform implements model-based design, a standard approach for describing embedded systems. LiCoRICE models can be conceptualized rather simply. Models have inputs, called sources, outputs, called sinks, and blocks in between, called modules. Each of these entities are implemented as independent processes on the Linux system. Information flows between these entities through signals, which are implemented as NumPy arrays mapped to shared memory, so they easily cross process boundaries. This design choice also means that signal reads are typically a zero-copy operation. This general approach is useful because it minimizes the amount of code that needs to be written. Sources and sinks only need to be written once for a given peripheral and can be reused for all models. To create a working LiCoRICE model, users will typically only have to write the module code and then wire signals between entities. LiCoRICE transparently handles all the messy details of compiling the code to binary executables, execution timing, and signal data flow. Modules can be written in C, but importantly can also be written in Python. Further, modules performing only NumPy operations are particularly optimized, as they not only incorporate BLOS and LAPACK, but are also statically compiled via Numbuzz PyCC. The resulting binaries are high-performing because they are not linked against the Python API. It's this abstraction of numerical operations to a high-level programming language like Python, combined with modular, reusable code on the edges of the system without the need to write low-level drivers thanks to the Linux kernel, that makes LiCoRICE a compelling platform for embedded systems rapid prototyping. The source code is distributed under a GPL license, and the project homepage is licorice.stanford.edu. Happy crunching!